Okay, let's begin these notes by just reminding ourselves of some things you've known for a long time. 6 divided by 6 is 1. Negative 7 divided by negative 7 is 1. Really, anything divided by itself is always 1. Okay? This is a fairly old and obvious fact to us now, but it's going to be key to what we're learning today. Here's something else that's fairly old and obvious to you now. 13.5 times 1 is 13.5. Negative 5 times 1 is negative 5. And anything times 1 is just itself. Okay? So we're going to use both of these facts to do something new today. We've got more radical expressions to simplify, and here's what I don't think you could possibly know or imagine unless I told you. Simplifying radical expressions means no radicals allowed in denominators of fractions. I'm not going to try to explain to you why that is an important aspect of simplifying radical expressions. Now you can see all that on the screen. No radicals allowed in the denominators of fractions. It's not that this is illegal or invalid or undefined or there's no such number. You can put this in your calculator. The calculator will understand this. It will calculate an accurate decimal approximation for this. It's just that mathematicians don't consider this to be simplified. And it would be difficult for me to explain why. I'm going to bypass that for this lesson, maybe in a future lesson. For now, you just need to know that if I ask you to simplify an expression that has a radical in it, and furthermore that it has a radical in the denominator, that you have to do something about that. You have to change the appearance of that fraction. Not its value, just the appearance, so that it doesn't have a radical in the denominator anymore. So we're going to go back over to the first one. And again, I'm not going to ask you to guess what we might do. I'm going to tell you simply, we're going to multiply this by the number 1. But don't write down times 1, just write down times. Because I don't want to change the value of this fraction. I only want to change its appearance. And we know that anytime we multiply things by 1, those things don't change. Anything multiplied by 1 is still itself. So I'm going to multiply this by the number 1. But I'm going to multiply it by a crazy looking 1. And again, up at the top of the page, here are some crazy looking 1s. 6 divided by 6 is the same thing as 1. Negative 7 divided by negative 7 is the same thing as 1. So I'm going to multiply here by a fraction. I want that fraction to be equal to the number 1. So whatever I put up here, I got to put the same thing down there. Otherwise, it's not equal to the number 1. And what I'm going to choose to put up here and down there is the square root of 3 over the square root of 3. Again, anything, no matter how crazy it looks, if you divide it by itself, that essentially reduces to the number 1. So I'm multiplying by the number 1 here. And I'm going to carry out this multiplication. When we're multiplying fractions, you multiply straight across. 7 times radical 3 is 7 radical 3. And radical 3 times radical 3, I'm going to do it step by step here, is radical 9. But what is the square root of 9? Square root of 9 is the whole number 3. And up here in the numerator, I still have 7 radical 3. So there, I have an expression which is equal in value to the original. You can check this. Put these both in your calculator. You'll get the same decimal value right out to the last digit. But mathematicians like this one better. They consider it more simplified because there is no radical in the denominator anymore. Okay? So, moving on to number 2. Again, every one of these 6 problems, I'm just going to multiply by the number 1, but that number 1 is always going to be in some crazy looking fraction form. Only this time it's going to be square root of 2 over square root of 2. And now maybe you could guess why I'm making that choice for this problem when I made a different choice for this problem. Do you see why? Well, let's just carry this one out and then I'll come back and I'll explain. Let's multiply these fractions across. 5 times the square root of 2 is 5 radical 2. And square root of 2 times square root of 2 is square root of 4. But that is just the whole number 2. No more radical in the denominator. There's our simplified version of the original expression. Okay. So on to number 3. I'm going to multiply this by a fraction again. What am I going to put in the numerator and denominator this time? How do you know what to put? Maybe you know. The key is whatever is in this denominator here. That's what you put in the numerator and the denominator. Because then when you multiply the denominators, that's what's going to get that radical to disappear. Square root of 2 times the square root of 2 is the square root of 4, which is just 2. And 6 times the square root of 2 is 6 radical 2. I didn't do the middle step there of making that denominator the square root of 4. I just kind of moved on past that to get to the denominator without the radical in it. So here we go. No more radical in the denominator. But if you circle that, it gets marked wrong on the quiz. Because I want you to simplify this expression completely, which first of all means get that radical out of the denominator. Okay, we did. But next you have to recognize that this can be reduced. Come on, that's old, old, old news. 6 divided by 2 is 3, and so you should change this to 3 radical 2. Otherwise it's not simplified completely. Okay? And please, come on, we're in high school math now. Don't reduce this to 3 over 1 and write 3 radical 2 over 1. I mean, that's not wrong, it's not inaccurate, but you shouldn't be writing over 1 if you don't need it, and we don't need it. So please don't do that. The next 3 are really very much the same. I'm going to go through them pretty quickly here. Multiply by square root of 3 over square root of 3. Because the denominator is square root of 3, multiply across and you get 15 radical 3 over square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. Can this be reduced anymore? Can it? Yes. That can be reduced to 5 over 1. So 5 radical 3. Don't put the over 1. We don't need that. There's your final answer. Last 2. Okay. These can be a little bit tricky also, especially dealing with the ones that don't need to be there in your final answer. Let's multiply this by radical 2 over radical 2. What is 1 times radical 2? What is it? Well, congratulations if you said radical 2 and not 1 radical 2. It's not that 1 radical 2 is wrong, but we don't need the 1. Square root of 2 times square root of 2 is square root of 4, and the square root of 4 is 2. There's your final answer. And then over here, multiply, we got a different denominator this time, square root of 5. So multiply by square root of 5 over square root of 5. Multiplying across, 5 times radical 5 is 5 radical 5, and square root of 5 times square root of 5 is square root of 25, and the square root of 25 is 5. Does this reduce at all anymore? Yes, it does. Those reduce to a 1 radical 5. Don't write 1 radical 5, please. It's not wrong. It just doesn't look like you graduated from junior high to high school. Please just write radical 5. That's your final answer there. All right. For the homework, page 2, I'm going to give you a quick glimpse of it. Page 2, the entire page is these kinds of problems. Well, I didn't number them properly. I can see here. 1, 2, 3, 4, 5, 6. This should be number 7, and this should be number 8. All 8 of these problems are like what we just did. When you get to page 3, these problems combine the kinds of problems we learned to do yesterday and the kinds of problems we learned to do today, and they're all mixed up. So please be careful. You need to think about how each expression needs to get simplified. The back page of this handout is something I just did at the beginning of class today, just kind of as a review of the things we did yesterday in class. This is not really part of the homework. You don't have to do page 4. It wouldn't hurt, but it's not officially part of the homework assignment. Good luck on the homework.